Hello everyone and welcome back to my YouTube channel. This is the ninth video in our machine learning series and I am Kisle Pandey. In today's session we will discuss regression modeling, its key types, evolution techniques and practical implementation using R and Python. By the end of this video, you will have a solid understanding of how to apply regression models effectively in real-world scenarios. So let's get started. Let's begin with the basics. Regression modeling is a statistical technique used to estimate the relationship between a dependent variable, often called the outcome, and one or more independent variables, also called predictors. It's widely applied in fields such as sales, forecasting, price predictions, and analyzing relationships between variables, making it a cornerstone in data analysis and machine learning. There are several types of regression models to address different data characteristics. Linear regression, a straightforward model that assumes a linear relationship between dependent and independent variables. Polynomial regression, this handles nonlinear relationships by lifting a polynomial equation to the data. Logistic regression. While its name suggests regression, this is used for classification tasks. It predicts the probability of an outcome belonging to a particular category. Once you build a regression model, evaluating its performance is crucial. Here are some common matrices. Mean absolute error MAE. This calculates the average absolute difference between the predicted and actual values. Mean squared error MSE, similar to MAE but squares the differences to penalize the larger errors. Root mean squared error RMSE. This square root of MSE, which makes it more interpretable, R squared, measures how much the variance in the dependent variable is explained by the independent variables. Let's see how to evaluate a regression model in R using the Boston housing dataset. We load the data and split it into training and testing sets. Train a linear regression model using the training data. Predict outcome on the test data. Finally, calculate metrics like MAE, MSE, RMSE, and R square. These matrices provide insight into how well the model fits the data. In Python, we use libraries like scikit learn for a similar process. Load the California housing dataset and split it into training and testing sets. Train a linear regression model. Use the trained model to predict the outcome on the test set. Evaluate the model using the metrics like MAE, MSE, RMSE, and R square. Both R and Python offer efficient tools for regression modeling and evolution. Stepwise regression is a variable selection technique. It generally adds or removes predicts based on their statistical significance. Advantages: simplifies model by selecting only significant variables, reduces computational complexity. Limitations: ignore multi-collinearity among predictors, can overfit or underfit if not used carefully. In R, we can use the step AIC function to perform stepwise regression. It systematically evaluates subsets of predictors and selects the best ones based on cross-validation. The output highlights the most relevant features for building a regression model. While stepwise regression simplifies the modeling process, it has limitations. It may miss complex interactions between the predictors. There's a risk of overfitting with small datasets. Use it consciously and also validate the results using robust testing methods, which I had recommended in the above slides. And that concludes our session on regression modeling. We explored the theory, practical implementation, and evolution of regression models using R and Python. If you found this video helpful, please like, share, and subscribe. Leave your questions or feedback in the comments below, and I will be happy to answer them. Thank you for watching and stay tuned for more videos in this series.